Hello friends, welcome to FoxuTech. Today we're gonna see the next important topic, Graceful shutdown, right? So when we are discussing about Kubernetes, one of the key role for the Kubernetes is terminating the pods and bring back the application up, right? It may happen due to various reasons, right? The reasons we're gonna see it in the coming slides. But what is the key responsible for the Kubernetes here is, so it has to be terminate the pod and it should bring up the application very immediately. But there will be a key things we have to understand about it. So in this tutorial, so we're gonna see about how the Kubernetes is terminating the pods, and beyond that, what all the operations involved. And also we're gonna discuss how the Kubernetes can shut down the pod gracefully and bring up the application very faster, and also we can avoid any kind of a downtimes, right? So let's jump into that. So when we see about the pre-Kubernetes or pre-containers world, so we know that all the application runs on the physical VM, or there will be a virtual machine runs on the VMware, right? So it will be running on that, and but in case there is any kind of a failure, so the application goes down, and it takes a lot of time to bring the application up, or it will be needed a lot of manual effects. So one could be like some of the engineers should be engaged, and he has to jump into that. He has to fix the issue, and this application should bring up online. So this kind of issues which need a lot of effect, and also there was a lot of downtime we were seen earlier, right? So if you are from SRE side, or if you are from the old Linux support or Windows support, you may have seen this kind of issues earlier days, right? So later what they do, where they made it, so they brought something called like monitoring tools or scripts. So with the help of monitoring tools, what they were doing, so they were started monitoring the processes. So with the process monitoring, so it will just check how the application running, and it will pull the exit codes. If it's running on the Windows environment, it check the exit code is 0 or 1, or it's except 0, any other will be treated as a failure, right? So in that case, it will be keep check the status code. In case there is any failure status code received, so immediately what this tool does, it will just trigger the restart script, and the application will be restarted. Okay, so then application will start serve to the users, right? So this was the followed earlier, but we have to maintain the separate monitoring tools, or we have to manage the script, and there is a multiple version has to be evolved with, right? So those kind of issues were there, and it was very complex to manage such ecosystem, right? And when it's coming to the Kubernetes, there is no attack, or there is no manual effects needed, as Kubernetes it should be meant to monitor the system and compare what state it should be, and bring back if there is any failure or any unexpected states of the system. So it will be doing on regular basis. This is not a one-time work. So Kubernetes does each and every time. So part of that, if it observes any kind of issues, immediately it terminates that particular pod and brings up the pod online at any kind of a given scenarios, right? So there will be a different scenarios pod can go. So let's see that our pod get terminated. So let's see couple of examples. What could be the reasons? So one could be you may forcefully deleting the pods, right? So on the time it has to be terminated, or there will be some resource issues. If Kubernetes notice any pod is running out of resources, or particular node is running out of resources, right? It's immediately terminate the application and make sure the node is having enough resource, right? Or what happens, so you are removing the particular node from the cluster. Let's assume it, right? So what happens, whatever the pods associated to this particular node, immediately Kubernetes just terminate that and move to the next available VMs, right? So this is all the situation related to process and the resources, it may fail. It may get terminated and it has to move to the next VM and it will bring up the application immediately, right? And there is another reason also will be possible. One is like a rolling update. Let's assume you are running application with V1 and now you are upgrading your application to V2, right? So on that time, what happens? You have to run the rolling update things, and what happens? This old one will be terminated, and a new pod will be started running, right? So how this operation runs? First, the new pod will be created, and once this is running, so the old pod will be terminated, and all the traffic will be moved to the new version, right? So these are the reasons your pod get terminated, right? So how this this all the operation may be running very often or very regularly, okay? So that may be the thing, but even though, right? So we have to make sure the application is not get stuck at any given scenarios. Let's assume you are running application with V1 and you are moving to V2, but some case your application is stuck in V1 for a long time or it got forcefully removed, right? So what happens when you do forceful removal? So your users may be impacted with, if anyone is still connected to this system, they will receive a failure note, or they will say their connection will be forcefully disconnected. So in that time, what happens? So they will be get notified as downtime, down, right? So that will be treated as application down, or the application may not respond properly on the time. So again, it will be another issue for us, right? So how we can overcome that? So this forceful shutdown should be avoided. Any application, if you're working from a long time in the IT sector, so any application you should not just kill it, right? Maybe that may fail due to lot of issues. One issue can be that application still may have a DB connection that get dropped unexpectedly, right? Or that maybe some service may be running for a long time, or some process may be long running process may be running that get terminated unexpectedly. So these all the situation will be occurs, and we should avoid such a scenarios. Let's see that how we can avoid it, right? Before jumping to the termination part, so I would like to recall our pod creation section. So we have seen in the last video. So let me add that video link in the description. If you like, you can check, or if you've seen, it's well and good, right? So what happens when you do pod creation, like a kubectl apply and your manifest, or you are running kubectl run command and you are creating a pod? What happens on the time? The particular kubectl request has its API call that will be sent to the API server first. From the API server, it will be set to this scheduler. So there is even the etcd get update, but I'm just going with a quicker way. Scheduler will check available nodes, how many nodes there and which can be fit this particular pod. Okay, so it will say, okay, there is a one of the node is there and this is a node, it should go like that, it schedule it, right? So what happens next? This kubelet, the kubelet from the node, it's keep poking the control plan and ask, is there any pod for me, like that, or any task for me, right? It's a pulling method, it works. So as scheduler is already set, this pod has to go to this node. So when that particular kubelet asks, control plan assign the task, yes, you have a task to do. So this is the details. Okay, it gives the details to the kubelet. Once kubelet receives that, what does? It will check CRI, CNI and the CSI, runtime and network and storage. If there is any kind of a storage is there, CSI take care. CRI take care of running the image and pulling the image to a spot, and network responsible for networking operation like assigning the IP, those details. Okay, so these guys take care of all these operations. Then it will update, hey, this is the IP, and you can like that kubelet will be received. Okay, now what kubelet does, it will go to the control panel and say, hey, I have successfully launched this pod and this is running with this IP 192.168.0.1. Okay, this is the IP. So what happens control panel? Then it shows to the user, or when we are seeing a kubectl get parts, then we will see running condition. Until then, this pod operation will be wait for the acknowledgement, right? So this is the operation, please be remember. But you can see this all the operations run sequential manner. There is no parallel work or there is no skipping part anything. It goes one by one. Okay. So, but when we discuss about termination, right? The operation is always parallel. Okay. So there will be a same time whenever you given a delete part command, it triggers both the operations or subsequent the next level operations immediately. Okay. What are the actions? There is a two action runs. One is happens on control pan and another thing happens on worker. Okay. In control pan, so it will just ask update to the endpoint controller to remove the whatever the endpoint. This is what request I got. If you have any entries, you should remove it. Obviously, there will be entries if they are running beyond services. So endpoints contains endpoint details, right? So if you check that, then it suggests to API server to can you please remove this IP and port from the endpoint. Okay. So these are the details it's given, and those details will be removed from the API server. Once API server updated it, immediately the changes should be populated to kube proxy. Okay, any modification done respective to the IP or something network related, kube proxy should be informed. Why? Because kube proxy is the responsible for updating the DNS, ingress, service message we have seen in the part creation section, right? So here you can see kube proxy receives that detail. Hey, this is the detail. Then what it does, goes to the respective resources, what all the things it's using, kind of ingress, IP tables or core DNS or any kind of networking services. It says this is IP should be removed because that pod is no more exist, right? So with that, this one set of operation happens on parallelly in the worker node, right? In the worker node, kubelet receives the request to remove the pod. Then it check, okay, this is the pod details. This is the manifest they given, right? Those manifests will be shared to the CRI, CNI, CSI, and nothing but container runtime interface, network interface, and storage interface, right? Storage interface responsible for removing any mounts are available, it will be just unmount it. Network is responsible for if there is any kind of IPs assigned on any kind of network resources located, everything will be removed. Then comes to the CRI. CRI is responsible for stopping that particular application or the container or pod, right? So how this happens? What is the request it's passed? As you know, like it's passed term signal. What is term here? Signal termination. So it's in Linux there is a 15 kind of signal sense for stopping the services. So part of that there is a two signals are most important for any kind of shutdown or any kind of a stop. What are those? One is term, another one is kill. Okay. So what is term here? Term is nothing but it has a graceful shutdown or it wait for the response from the particular application. What kind of response? Term first says, hey application A, I have received, you should be stopped. Okay. So then it says, hey, application response, hey, I have some process to complete, let me complete quickly. Okay. So term, okay, there is something is running, I have to wait. Okay, it takes little time. It has some sort of time period. It's wait for it. So then until then, term will wait. Okay. So still this is good, right? So obviously because it's waiting for existing process to complete. Let's say in Kubernetes how it's designed, first signal will be sent as a term, obviously. Then next 30 seconds it will wait. Okay, in Kubernetes there is a 30 seconds of time interval. Within the 30 seconds, if the application responds, hey, I have completed my work, then it's well and good. Immediately the term stop the application and the pod will be removed. But let's say like this, the pod is not responded even after 30 seconds. What Kubernetes treats like this, what Kubernetes does, it looks like this pod is not responding, that is no more my responsibility. Immediately it sends a signal called sick kill. Sick kill is nothing but it doesn't bother anything. If someone says, it's just follow it. If someone says to kill, it's just take a gun and it shoot it. But sick term, it's not like that. Sick term will be like a poison. It's killed slowly. Okay, it's wait for the certain for trigger point, then it's wait killed. Right. So sorry for the bad example again. So, but this is it maybe matches here. Sick term is kind of a slow poison, but sick kill is just shooting on the gun. Right. So this way, within 30 seconds, your application will be completely removed. But again, that's not expected. Why? Because as I said, still there will be existing connections should be processed. Let's assume like your users are connected or your client is connected some cases, right? So those kind of scenarios will be completely unexpected, correct? So this is what it does, still it does, okay? This is what we're gonna see how we can improve this complete operation with some best configuration settings, or what is the best practice we can follow to avoid this kind of unexpected shutdown or something, right? So we're gonna see that shortly, but let me explain this in another way. So we're gonna see another example here. So that's one thing, okay? So here we can see still this is all like everything is updated, still this is failed or this killed unexpectedly. But let's assume your pod is killed successfully, okay? There is no extra process or anything is running. So it's smoothly it's killed this the container in let's say 10 seconds, okay? Within 10 seconds, the container has been checked and Kubernetes will send a sick term signal. Container checked. Okay, I'm not having any kind of a external connection, or I'm not having any DB connection, or I don't have any process to run. So I'm good to get stopped. Correct? Right. So now, as he is good guy, we have this guy got stopped. Well, but as I said, so there is a parallel operation running on the control plane, right? What is operation? It has to update the endpoints to the respective networking part, correct? So let's assume this operation completed quickly, but still the old of this operation is getting delayed. As there will be a networking operation, maybe running or some case the ingress got busy with some other request or something. Obviously, there is some expected delay, right? So in that time period, let's assume this request is still in a waiting period, but pod is got killed, as ingress is yet to get informed, correct? So ingress is doesn't know the endpoint is to be removed or the pod is down. Still it thinks like still this ingress has a endpoint table, right? We have seen in the pod creation, it has a entry. Still this entry is present on the table. So what happens when there is a new request comes? It checks the table. Okay, the pod request is the pod is there. This is your IP. Just go to the particular pod. But when the request comes here, if you are doing a service upgrade, well and good, there will be alternate IP will be given. But as there is no such operations performed here, your pod is not present. So the user will see 404 error or any kind of error, however it's processed. So the error will be displayed to the user. So what user thinks? He thinks the application is down due to some issues or there is application down. So let's assume this is got from the monitoring tool and your monitoring tool reports to your client, and there will be endless stories, right? So they will ask a lot of questions, what is happened and why it's happened. So those kind of things will happen, right? So this kind of things should be avoided, because if there is a delay, that is, if you know there will be a delay, then you should be very precautionately focused on this and you should tune your configuration. Otherwise, this kind of unexpected issues, right? So yeah, see what we have, it has to be done, it's done. right? But still there is some operations are pending, but still your users are affected. So we should always avoid any kind of issues within internal. It's fine, but when it's coming user base, we should be very careful. That is our primary role as a DevOps engineer or SRE or Ops guy, right? The modern world DevOps guys, right? Anyone. So our responsibility is keeping an application 100% is not possible, at least 99.9999%. Or we should not make any kind of a known error or human error, right? Right. So how we can avoid this? Yes. Is it any option is given by the Kubernetes? Yes, in Kubernetes there is an option. What is that? So Kubernetes gives pre-step command, right? So pre-step is one of part of a life cycle of pod, and it executes certain commands for make sure this kind of issues can be avoided. How this is helpful? Okay, so let's see that. So what happens, correct? So yeah, let me take another slide here. So you can see it here. So now, as you see, there is a pre-stop we have implemented. With the pre-stop, what happens? As there is a request immediately processed on last slide when we see. So here you can see there is a subsequent actions are done immediately. But when you are running with the pre-hook, this operation will be delayed for 10 seconds. Correct? So within this 10 seconds, what happens? Your kube proxy, IP tables, everything will be removed. On high level, if you say the endpoint has been removed from the table, correct? From the ingress or service mesh or any kind of a networking section, there is no more endpoints. So what happens? Even the user try to connect, it won't connect or it won't wait for the pod to respond or anything. There is no operation will be allowed. So this operation will be invalid, right? Now we are safe, correct? In backend, so that request is completed as we waited up 10 seconds. In additionally, there is an additional 20 seconds, let's assume, right? As we have only 20 seconds, even though the pre-hook, whatever we are implementing here, please be noted, this is within the time 30 second cycle only. It's not beyond the 30 seconds. We are just enforcing the request. Sorry, we are passing the request for 10 seconds. Then within next 20 seconds, the pod should take a responsibility of draining any kind of a connection, or it's running with any kind of a process. It should be get stopped. Okay. So that is again within that limit. Correct. So this is what happens. 10 seconds for pre-hook, 20 seconds to complete the container operations. Now what happens? As there is no request comes here, obviously there is no new connections will be allowed. Correct? Second thing. So now as you see the pod is completed in 30 seconds, now pod is deleted. So whatever the existing connections are there, it will be completely processed. In some case, even though this is not processed, okay? So even though if you say this is not processed, immediately there will be a seek kill will be passed and this container will be killed, okay? As it's within a 30 seconds still, okay? We are just still speaking about 30 seconds of cycle, 10 seconds for pre-hook, 20 seconds for container operations. Use this number, it's not a static 10, you can keep 20 or 25 based on however you are expecting this wait period. After that, how quick your pod can be stopped, right? You can decide this number, but make sure within 30 seconds, only if you are using pre-stop command. But it's not the case, right? Sometimes if you are running with some critical long process applications or something called like machine learning algorithms or video streaming service or video processing service, there will be a number of use cases nowadays. We are expanding the Kubernetes. So any one case, this may not be a valid for us. As 10 seconds or within 30 seconds, it's not easy to complete. Let's assume you are running some critical application process which runs some kind of algorithm or some kind of a data processing or video processing or any streaming process, anything, right? It's running for 6 hours or 5 hours, and you are middle of that process, and this kind of a sick kill got paused, what happens? Your certain period, that period of time, whatever you spend, like 3 hours or 4 hours, these complete hours are wasted. Again, we have to start and think you are running in some critical delivery has to be there, and this kind of hours cannot be wasted, correct? So how we can avoid such issues? And is there an option? Yes, there is an option. You can enable, there is additional configuration called termination grace period. Let's assume you have such a expected scenarios, so you need some extended process time. Okay, let's say. So on the time, what you can do, you can enable such a time period here. This time period can be higher than anything because this is out of the 30 seconds. When we say this pre-step, this is part of pod, and this is 30 seconds is part of that. But when we say termination grace period, it's beyond that limit. Let's assume your application needs 2 hours. In the sense, you can configure 2 hours here, and that process will be take to complete 2 hours. And but meantime, your allow user process will be complete dropped, right? So let's see that how it works. Let's assume you have enabled the termination policy. Okay, so grace period you have enabled, and I'm gonna consume this time period you given like a here 45 seconds I given, but let's assume like a 1 hour. Okay, so you have enabled this as a 1 hour, right? So you have given 1 hour, but why you need a 1 hour? Because you are running some large set of algorithm which obviously runs every hours or long time of hours, and unexpectedly it started triggering, right? We can't kill it because 1 hour we have to rerun, we have to wait, or we have to do all the drama again and again. So let's not do that. So what we have given, we have that grace period of 1 hour. So what happens with the grace period? If you enable like a both pre-stop hook, and also you have enabled that grace period. Okay, as I shown here, you have this pre-stop also and grace period also. Okay, so you have enabled both. Now what happens? Obviously the control plane step will be completed. IP tables will be removed the 10 points, correct? So your no connection will be allowed within, let's say this takes some worst case, it takes 45 seconds. Till this 45 seconds, your container can serve the traffic to your users, right? Because till your container is not stopped, as we given the grace period, this particular application will be keep on running until this grace period expires. Okay, so let's assume this took 45 seconds. So within still the 45 seconds, this application processes the request and it responds to the users. Beyond that, even it takes 30 minutes also, this happens, this operation will be still processed, then only this will be get shut down. Okay, so okay, so now we have achieved this, then it will be dropped. So let's assume now within let's say like after 45 minutes, or let's say like after 1 minute, let's not take long. So after 1 minute, what we did, so this is 1 hour and this took 1 minute to complete. So these operations are completed here, right? So 10 seconds pre we given. So remaining seconds, whatever it's there, this will be within this 1 hour, and this till then the application will be up and running. So meantime, what happens? Whatever the existing connection or existing process are still will be processed by your application. But you can ask me the question, right? What, as there is no traffic, what is the use this part need to be run? How do what my user will do, right? So right. So what you can do, parallelly you can start your another application. Okay. So ask why you are stopping that. So maybe let's assume like you have did some rolling update, correct? So with the rolling update, this kind of things will be handled. Let's not assume update, there is something happened, right? So within that, my pod is still get terminated. Okay, as there is no traffic and this pod is still down, you can launch a new pod, right? Or if you say within that, this time is very high, I given long running process, this it has to be followed like this, but this is 1 hour is very high, I'm speaking here. So when there is no, so you can create a new pod. So with a new pod, you can start serve the traffic to your users, and your users will be still accessing your application. Okay. So this way is like a for the pod, but let's say like you are running some kind of a rolling updates. Okay. So it's a rolling update. What happens? So when you are running a rolling update, so you have again you set 1 hour and you are running a version called V1, correct? So your traffic is already dropped. Now you are in a force to deliver the application because your already V1 is still in the termination state. It's not in the running state. ETCT will treat this as a terminating state. Okay. So your users should not get affected. What you have to do? So V1 is running right with this grace period. When you do rolling update, immediately Kubernetes takes that part. It will create another application with the V2, whatever the image you given. So it will be create this layer, and whatever the request is comes, it will be passed to the kube IP table and it's update everything end to end as the part creation section. New pod get created and user will start seeing a new application version, right? As like a previous pod. But what is happening here, right? So still your application is in termination state, but still it has a existing connection. You can see it here. This is new request only. It will be processed to V2, but any existing connected application users will be still using this V1 connection. Or let's assume you are having a WebSocket connection or some kind of wrong processing request, right? That cannot be broke immediately. If in case, let's assume you are having application which is delivering the metrics every second to your client. So you can't stop this because client will be affected and you will be completely stuck and you may get escalated from the client, right? So this kind of things happens, right? So what happens here? So though still this won't happen because still we are running this pod for a long time beyond the certain limit, and until this get disconnected or this user right to 1 hour, right? This process will be keep on running. If in case there is some trigger is happened, so when the next cycle happens, they will be automatically moved to V2. Any connected users, in case they got dropped or anything, so obviously they're gonna connect it to V2, but they should not see any kind of a downtime. That is ultimate goal, right? So with this kind of implementation of termination policy, with a long running process, will be more helpful here, right? So this will be one of the key things you can try out. But again, this is something. So this is something you have to check about it. But it's not recommended if you are running any kind of a process. Just have an understanding about how it works and try to implement lesser number of grace period and bring it down. In case you have to run a long running process and something has to be done backend, you can run it. As I said, you have to launch a parallel connection. You have to go for if you are doing a rolling update, then it will be a risk because it will be having issue. We may recommend you to go for the completely new deployment. Okay, so instead of rolling update, you can go and create the new deployment, and with the new deployment, already V1 is running here, V2 will be running. There will be a different layers, and this will be started serving a traffic. But V1 still running some process and it runs. So this process called rainbow deployment. So this is called rainbow deployment. So what is rainbow deployment does? So with the ingress, you can see still old one will be running, current cycle also running, and even you can bring up the new next layer in the pipeline. Okay, so you can keep everything, and still all the connection can be used by the users or any connected resources. But whoever connecting currently, a current process will be processed only to new, but who all connected from the existing VMs, they will be still connected to old one. Okay. So with that, you can achieve a zero downtime mostly. So because still the old connection won't be get dropped until user get dropped. but the new service is already ready. So in case if they got dropped to their own internal reason, so immediately they can switch to the new version, right? Already we have proved this. So with this kind of scenarios, you can pick any one of the solution and you have to implement. Mostly try to avoid this long running process termination grace policy until unless you have a long running process or long running requirements. Okay. If you don't have anything, so it will be very quicker and very straightforward with a just 4 to 5 lines, you can achieve the very best termination policy or very good graceful shutdown. Or if you are facing any kind of external issues, something called like it has to be run for a long time. So then you have to think about this rainbow deployment kind of a deployments, which will be running V1 and V2 parallelly. V1 will be out of, it will be within the cluster, but it won't expose outside. V2 will be exposed to all the users. Okay. You can ask one more thing. So as V1 is running, it will be get terminated or get cleaned automatically. No, it won't get cleaned automatically. Or let's assume you given like something long, very long hours, 10 hours or 20 hours, and you have to keep monitor that and you have to come and delete this manually. Okay. So again, you can ask, why should we do manually, right? Because the modern world, we like to do everything automated way. Okay. So in that case, what you can do, even that is possible, you can do something called like auto scaler. So what autoscaler does, it check your pod, and if there is any traffic or anything is there, it will wait. If it's check and if there is no connection, no process running or nothing is doing right, immediately it will bring your application, the old application to 0. Right? So with that, what we did now, so your even old one will be cleared perfectly and new one will be start serving the traffic to the users. So with it done, so this will enable us to do 0 downtime, right? Also, we are doing a graceful shutdown with certain the things called like a terminate grace period. Okay, so this kind of values will be so useful. So you should be aware of it. Check about your application deployments and environments. Is it any such issues? Any kind of misconfigurations are there? Always, even though if you don't know about it, so just check your application and understand your application and define such a number. So those kind of values is so helpful when to avoid any kind of unexpected downtimes. Okay. So hope this video is helpful, guys. Hope you will find you learned something new today. So please share your thought. If something is not clear, please let me know. I can try to explain you guys. And we have a social media page. So you can follow us even in the social media, Instagram or something. So there we regularly post some kind of tricks or some kind of familiar commands or troubleshooting commands, like how you can list, how you can switch the namespace to the current namespace, or how you can pull the current namespace values, or how you can list some commands, right? How you can install some packages with some certain 1 or 2 line commands. So those will be keep on published on our social media, Instagram and Facebook. You can follow us. So that will be more information to you, and share your friends if you like. So they will also get benefited. Please invite your friends also and let them also know about this kind of detailed case shutdown or pod creation details, and we will be covering that on regular basis. Hope this is helpful, guys, again. So thanks for your time. Thanks for your session. Have a great day. Keep learning, guys. We'll meet you again on next video. Thank you. Bye-bye.